He's asking if the recording is on.
Yes, I have started recording. Mm, mm, mm. See, if three sites are connected through internet, here I have two options. I can have full mesh IPsec or VPN, right, between router 1 and router 2, one tunnel between router 2 and 3, one tunnel between router 1 and router 3, one tunnel. Means all the sites are directly reachable with each other. Here you can read the description about hub and spoke topology. Like you will have one centralized, one central hub router which will be connected with multiple spoke routers. One main router. From here you will manage all the routings like hub, spoke to spoke site communication. All traffic will go through hub. Let's suppose you have one data center and multiple sites, and you want to configure centralized security policy. Means you have centralized firewall in the data center, right? So what you want, between the branches all traffic should go via DC, so that in the DC I have firewall. There I can inspect the traffic. Inspect means by, like, I will check who are you, where are you going. Let me see the policies, pre-configured rule, you are allowed to go there or not. If you are allowed, it will forward, otherwise discard. That is centralized security policy. Means we have central firewall, one firewall, and securing the traffic from all the sites. There you will configure hub and spoke topology. Means there will be no any connectivity between spoke 1 and spoke 2. This topology or scenario is quite simple, simpler than your full mesh topology, because in full mesh you will have all the sites connected together, right? So on all the routers you will have two VPN. If you have three sites, if you have four sites, you will have three VPNs on all the routers. If I have 100 sites, that means I'm going to manage lots of VPNs on one router. So both topology are real-time scenarios. We are using both types of topology, hub and spoke as well as full mesh. In both types of topology you have to learn routing. Then at the last you will understand, okay, if I am going to configure OSPF as a IGP protocol, then what should design, how I should connect multiple sites together, or how I should connect the devices in the LAN, means at core layer or between core layer and distribution layer, which we had discussed earlier. So here you can read about hub and spoke topology, right? Simplified management, easy to manage since all communication passes through the hub. It is cost effective as well, right? You are going to configure fewer VPNs on all the branch routers, and you need a good hardware at hub router in the DC or hub side. Fewer links are required compared to full mesh topology, right? Even more less links are required here. Here you can see the other advantages and disadvantage of hub and spoke topology. Single point of failure. If my hub router bill goes down, what will happen? Connectivity between sites will also goes down. So all the sites will become unreachable. Here we can use two hub as well, right, for the redundancy. But that is the issue in this scenario. When you have single hub and spoke, if you will add more hub site, right, again it is going to be quite complex. As much as you will be increasing the hub site, topology is going to become complex, right? Load on the hub router is going to be more. It is good for a small to medium size companies, right, where you have 50 sites, 20 sites, 30 sites, right? And cost is your, let's say, priority. If your priority is availability, your network should be always available. Google will definitely go with full mesh topology, because between branch 1 and branch 2, if we'll send data directly, then definitely delay will be less. If my traffic from R2 LAN to R3 LAN is going via router number 1, definitely delay will increase, because it is using longest path, not the shortest path. If they are forwarding data directly, there will be less delay. So the topology depends on various scenario. What is your priority? Cost, reliability. So here somewhere you can see that as well. Full mesh, all the routers are going to connect with each other. Okay, high redundancy, we have multiple redundancy even in 3 sites. You can see if all the routers are connected together, right? If this link will goes down, only communication will impact from hub to spoke 1. Spoke 1 and spoke 2 can still exchange data. Here the disadvantage is going to be costly and complex management. Generally in the large network, mission critical networks, we are using full mesh topology, where your priorities, high availability, performance, redundancy are the critical, and such data center and backbone network organization with high traffic requirements suitable for organization where cost of downtime is very high and performance is the priority. In that case, use full mesh topology. So in full mesh topology, like here we have seen EIGRP configuration, but here in hub and spoke topology we have not seen the EIGRP configuration. So first of all I am going to enable EIGRP here, and on the switch what I will do, I will stop communication between this port and this port, so that EIGRP never will not come up between router 2 and router 3. How I can do this on switch? I don't want to allow communication between this port and this port. I want to stop communication between two switch port. What you will configure?
VLAN.
VLAN? Really? Both are in same LAN then? Both are in same LAN.
STP.
STP?
Private VLAN.
Private VLAN.
Port security.
Port security. What is port security, sir? Port security is binding the MAC address of genuine device on the interface. Authorized user can only connect their device to the switch. Here I will configure switch port protected. Two protected port cannot communicate with each other. We know this, right? Imagine this is the VPN segment where my subnet is 192.168.1.0/24. So on R1, let me enable EIGRP and let me configure the subnet. Enable config p interface G0/0 no set and IP address 192.168.1.1.255.255.255.0 exit interface loopback 1 IP address 10.1.1.1 255.255.255.0 exit router EIGRP ES number let's say 10 and network 192.168.1.0 wildcard mask 0.0.255 and network 10.1.1.0 0.0.255. This is my configuration of R1. Let me
Sir,
access it.
here the Sleep Horizon rule is applicable or visible in this condition?
Yeah, we'll see it. We'll see if it is required, we'll enable. Wait. Okay, let me paste the command. Done. Let me configure R2. On R2, G0/0 IP will be 192.168.1.2 and here 20.1.1.1. Copy and paste it on R2. Let me access R3 also. All the commands are accepted. Let me configure R3 also. Here IP address is going to be 1.3, here 30.1.1.1 and here 30 subnet. Copy and paste it on R3. We are done with the configuration. This is my hub site. And this is a spoke 1. A spoke 1 and a spoke 2. Okay. So see, here we have enabled EIGRP. Router 1 is going to send hello message on multicast address. Right, both the router 2 and router 3 will receive hello message. Similarly, both router number 2 and router number 3 are also going to send hello message on multicast address. R1 will receive. But will R3 receive hello message of R2? No. If we will block the communication here, right now, yes. So right now, if I will take you to R2 and if I will show IP EIGRP topology, or sorry, show IP EIGRP neighbor, then you can see router number 2 has 2 neighbors. This is what? Full mesh topology. Right now all the routers are directly connected with each other. Similarly on router number 3 also, host name R3 and so IP EIGRP neighbor, 2 neighbor. Similarly on R1 also you can verify, R1 will have 2 neighbors, so IP EIGRP neighbor. Good. Now R1 is advertising this submit into EIGRP. It will advertise to again on multicast address, which will forward it to R2 and R3. R2 and R3 is receiving all the route. Even R2 will be receiving hub side route and spoke side route 10.1.1.0 as well as 30.1.1.0. Right? Who is advertising? 192.168.1.3 means router number 3 directly, because there is direct connectivity. Now on the switch I am going to stop the communication. Go to switch, enable config T. One minute. Interface range G0/1 to switch port protected. Now these 2 ports are protected, they cannot communicate. In full mesh topology,
Kapil, can I ask one question?
yes, sure.
So where did we get this 192, 1.3 and 1.2? From where did we get those networks?
Where I have configured 1.1, 192.168.1.1 on
Yeah.
G0/0 of R1,
Yes.
1.2 on G0/0 of R2, and 1.3
Oh.
on G0/0 of R3.
Okay. Got it. Thank you.
So in full mesh topology, when we had not blocked the communication between 2 switch port, everything was working fine. Now if you will check R2 EIGRP neighbor table, so IP EIGRP neighbor, you can see router 2 has only neighborship with hub router, because now router 2 and router 3 cannot become neighbor. Similarly R3, so IP EIGRP neighbor, R3 also has neighborship with hub router only, and hub router will have 2 EIGRP neighbor on R1, so IP EIGRP neighbor. Here you can see it has neighborship with both the spoke 1 and spoke 2. Now on spoke router, on router number 2, if you will check EIGRP routing table, so IP route EIGRP, here you can see it is only learning hub side prefix 10.1.1.0, the LAN subnet which is connected on R1. It is not learning 30.1.1.0. Why, guys?
Because of switch port protected.
No. What I am saying, see, R3 will advertise this 30 subnet to whom? To their neighbor. Who is neighbor of R3? So IP EIGRP neighbor. So IP EIGRP neighbor. 192.168.1.1 is the neighbor. So
Yes,
R3
R1.
will share this prefix, advertise this prefix to R1. R1 should update, learn it, and then it should advertise to their other neighbor as well. Go to R1, so IP EIGRP neighbor. See, it is learning from this neighbor. R3 should advertise to this neighbor now, to R2. But here on router number 2, we are not able to find this subnet in routing table. Let me show you topology table also. So IP EIGRP topology. In topology table also you can see 10, 20 directly connected. This router is advertising. sorry, this 20 and 192.168.1.0, and it is learning 10.1.1.0 through via which IP address? Via R1 IP address 192.168.1.1. Because of a split horizon, what I have told you, by default split horizon is enable. So if switch is learning receiving update message for 30 subnet on G0/0, then it will never advertise that from same interface, from receiving interface. So on router number 1, what I will do, I will disable the split horizon. Config T interface G0/0. By default, this command is enable. Split horizon IP EIGRP or IP split horizon for EIGRPS number 10. This command is by default enabled. If I will remove this command, say no to this, and then go to router number 2 and check routing table again or topology table again, you can see neighborship is resynchronized. So IP EIGRP topology. Now you can see 30.1.1.0/24 subnet in topology table, as well as in the routing table you can see 30 subnet. But still there is one issue. Any issue is there now? Now there is no any issue. Right now router number 2 can send traffic to router number 3, means spoke 1 and spoke 2 can talk with each other. Ping 30.1.1.1 and source 10.1.1.1. Sorry, source 20.1.1.1. See, ping is working. All the things are working fine. Now on router number 1, one more command is running. Interface G0/0 IP next hop self for EIGRPS number 10. This command is also running. If I will remove this command, then see what will happen. Many times we will remove this command from the interface, right? I don't want, let's say router 1 should update next hop IP address. Now see, so IP EIGRP topology. Now what is happening? 30.1.1.0, I am on router number 2 and talking about spoke 2, right? Branch 2. 30.1.1.0 is reachable via 192.168.1.3. So generally in normal scenario, what happened, because IP next hop self command is running on all the interface. A split horizon command is running on all the interfaces by default. So when R3 is advertising this 30 submit to R1 through update message, source IP will be what? 192.168.1.3. That source will become what? Next hop IP address on R1, correct? Next hop. And when R1 will advertise it to their other neighbor, it will update the next hop. It will update the source. It will update the next hop IP address, right? And router was getting this submit 30 with R1 IP address. But as soon as I have removed the command, now router 1 is not updating the next hop IP address. It is advertising the prefix exactly like router number 3 was advertising to R1. Now R2 has learned this 30 subnet with this next hop, and this next hop is reachable, not reachable from R2. So again, can ping work between these two sides? Not work. So here on this interface in hub and spoke topology, on the hub router, you have to disable split horizon and you have enable next hop self command. Then only your communication will work, right? There will be connectivity between the spoke sites. So this was the different in hub and spoke topology. Different behavior of EIGRP in hub and spoke topology. Only two things are there. Got it, guys? Next hop self feature in EIGRP. And see, one more thing. Here I am going to remove EIGRP now. No router EIGRP yes number 10. On router number 2 also. No router EIGRP 10. R3. No router EIGRPS number 10. I have removed the EIGRP. Now here router 1 was sending hello message, all message of EIGRP on multicast address. Here you know you have VPN between router 1 and router 2 and between router 1 and router 3. If there are some more router, connected with this internet or with this switch. In that case, what will happen? All those routers will be also receiving hello message of EIGRP because routers are sending on multicast address. Or if here you have point-to-point link between router 1 and router 2, on point-to-point link every time, remember my EIGRP neighborship should be static. There are two types of neighborship in EIGRP. Till now we have learned dynamic neighborship. Dynamic neighborship. Now we have another type of neighborship, that is a static neighborship for point-to-point link. In OSPF you will learn types of network like point-to-point, multi-access, segment, broadcast, non-broadcast in detail. No worry. Here we have another type of neighborship, that is a static, and in a static neighborship your all EIGRP messages will be unicast. Router will send message on unicast address, not on the multicast. See, again on router number 1 I am going to say router EIGRP ES number 10, and here I will define the neighbor IP address. In BGP you will configure exactly like this. BGP doesn't support dynamic neighborship. BGP doesn't support dynamic neighborship. Until and unless you will not run neighbor command, BGP will not discover the neighbor. So neighbor 192.168.1.2 1.2 neighbor IP address, and then interface. On which interface? GI0/0 interface. Right? Will router start sending hello message on this interface? Will router start sending hello message after running this neighbor command? Anyone have idea? Will it start sending hello message?
I think so.
No. Why?
No.
Because Praful EIGRP is not enabled on G0/0 interface. Do so IP EIGRP interfaces. See, EIGRP is not enabled on any interface. So I need to run command network 192.168.1.0. That's it. Now it will start sending EIGRP hello message. Here you can see, and destination address is unicast. Whatever neighbor you will define, it will send hello message to that neighbor only. No more multicast message on this segment. Right? Because switch is treating multicast as a broadcast only by default. By default, switch treat multicast traffic as a broadcast traffic only. Now on the router number 1, I will define one more neighbor. Neighbor 192.168.1.3. But we don't have any neighborship now, so IP EIGRP neighbor, because we have not enabled EIGRP on other routers. On router number 2. On router number 2, router EIGRP ES number 10 network 192.168.1.0. Will EIGRP neighborship come up, guys? I have just enabled EIGRP on G0/0. Will EIGRP neighborship come up? See, router 1 is sending hello message to 1.3 as well as 1.2. Here is the hello message of router number 2. Router 2 is sending hello message on which address?
Multicast.
Multicast address. That's why you don't have neighborship here. Statically now you here also you have to configure neighbor IP address. Because right now router 2 is sending hello message on multicast, and this interface is not member of that multicast group. So will it accept? If router is receiving any multicast traffic and that interface is not member of that multicast group, it will discard that. We know this. So router 1 is discarding. As soon as I will add the neighbor command here, it will start accepting. It will start sending actually unicast message 0/0. Done. Now I am expecting EIGRP neighborship. Here you can see, and so IP EIGRP neighbor, but it has not exchanged any route. So IP EIGRP topology till now, because you can see in the update message router will never include the subnet which is running on exit interface. We know that as well. Now on router number 2, if I will advertise 20 subnet, router EIGRP number 10 network 20.1.1.0 0. or wildcard mask 0.0.255, then go to R1. or here you can see the update message, and your update message is also unicast, correct? So now all the messages is going to be unicast on a static neighbor. For a static neighbor, all the messages will be unicast. Now we have covered the path manipulation. Also in the EIGRP, basic of EIGRP static neighborship, some other parameters like variance, offset list, and summarization. Now we are going to start route filtering in EIGRP. Do you guys want to practice more path manipulation?
Yes, yes.
Through variance, you know how we perform, how we are performing load balancing. Actually, that is not path manipulation even, that is load balancing, unequal cost load balancing. When cost is not equal, then you will configure the variance. Otherwise, through offset list, you can perform the path manipulation very easily. Through summarization also, you can perform the path manipulation very easily. I think this topology is already configured. Let me check. And I'm also going to down this lab. Is this scenario clear to all? In hub and spoke topology, here you need to run two commands. Like you need to care about next hop IP address and split horizon rule. Then spokes to spoke communication will happen. No problem. And one more thing is there, by the way, here, which you can understand if you want. Otherwise, you can leave it as well. See, if 30 subnet will goes down, 30.1.1.0, what will happen? R3 will generate what? Query message. You know,
Query.
R3 will generate query message for their neighbor, for R1, and R1 will send that query message to their other neighbor, to router number 2. But see, router 1 has only advertised this 30 submit to router number 2. Should router 1 generate query message? Yes, Praful, definitely it should generate. Otherwise, how router will remove it from their topology table? It should generate. Router 1 should forward that query message to R1 or not? The query message which R3 has generated for R1. Without query message, can EIGRP changes work here? Can I avoid query message here? Like
No.
I don't want router 1 should send query message to router number 2. That is one very small concept here, stub router. Okay, in one scenario, in upcoming one scenario, I will make you understand that, right? Here you will configure this router as a stub router as well. All the edge router of EIGRP as a stub router. You will understand the benefit, no problem. For now, let me configure some path manipulation here, and then I can make you understand the route filtering. For route filtering, till now we have only discussed access control list, right? Access control list to make the interesting traffic, to match the traffic. But we have some more features, security features like access list, prefix list, and route map. We'll discuss basic of route map and prefix list here, and in the BGP we'll understand the advanced route map concept. Do so IP interface brief. IP addresses are already configured. So IP protocol. Is any routing protocol enabled here? Not enabled, right? This is another application protocol. So router EIGRP as number 10 network 0.0.0 and do so history. Let me copy the command do so history. Whatever. Not able to copy. Enable config T router EIGRP ES number 10 and network 0.0.0. I am going to run this command on all the routers so that we can have EIGRP neighborship in between. R1 done, R2 Okay, R3, R4. If we have same bandwidth, same delay, then router will have two paths. Between source and destination, we will have two paths. Go to R1 and see EIGRP neighborship with 13.3. Why we don't have EIGRP neighborship between R1 and R2? So IP IP EIGRP neighbor. See, okay, two neighbors are there, 12.2 and 13.3. So IP route EIGRP, here you can see it is performing load balancing for this destination subnet. Why? Because the FD is same, metric is same, and this is AD value. Guys, you know one more thing. AD value defines the trustworthiness of route path. If any path has AD value 255, then router will consider that as unreachable. Route with AD value 255 will be never installed in routing table of router. Remember this. So if I will configure AD value 255 for EIGRP, it will filter all the routes. Router EIGRP as number 10. By default, all the dynamic routing protocol has one defined AD value, but you can change it. Distance 255, and from which source? Let's say from 12.1.2. From 12.1.2 and wildcard mask 0.0.0. Now wait for the synchronization, resynchronization. So IP route EIGRP, clear IP EIGRP. Okay, now neighborship is resynchronized. Let me show you the EIGRP routing table. Now you can see only one path is there because so IP EIGRP topology. In the topology table also you can see we have single path. So IP EIGRP topology table, all the link. Still we have this path, lower path. Reason, AD value from router number 2 is 255. What table prefixes router 1 will learn from? This neighbor 12.1.2. It will use AD value 255, and route with AD value 255 is unreachable. But apart from 255, you can configure other distance value for path manipulation within the routing table, routing protocol as well. Like here, see, right now router 1 is doing load balancing, but I want upper path should be my primary path and lower path should be my backup path, and we have single routing protocol, that is EIGRP. Sometimes you will have multiple routing protocol. There definitely AD value is going to be different by default, but within the routing protocol AD value will be same, right? Routers are not calculating the AD value. AD value is fixed. EIGRP uses total how many AD values? EIGRP uses how many AD values, guys? Three. One is, so IP route EIGRP, one is 90 for internal route, one is 170 for external route, for redistributed route. Soon you will understand that. And one for summarization, for summary route. In last class when I had summarized some prefixes, at that time AD value was 5 for that summary address. So EIGRP uses 3 AD value, but you can use any other AD value. Again you can see R1 is performing what? Load balancing for this destination. Here I want to configure primary and backup path. So router EIGRP is number 10, and I can configure distance more than 90, let's say 100. From which source? From 13.1.1.3 and wildcard mask 0.0.0. Now if you will check EIGRP routing table again, so IP route EIGRP, just wait for neighborship resynchronization and then you can check. Still it is doing load balancing. Now you can see AD value is 90, and now if you will check topology table, so IP EIGRP topology, then you can see for 192.168.2.0, where is 192.168.2.0? Here it is 2.0, two paths, one from 13.3, one from 12.2, and there is one successor. There is one successor. So IP route EIGRP best path. If best path will goes down here, config T interface G0/0 shutdown. If primary link will goes down or R2 will goes down, so IP route EIGRP. Now you can see traffic is shifted on lower path and here AD value is 100 via router number 3. Now metric is same on both path, but based on AD value distance you can manipulate the path. This is one more ways. Again I am going to remove that command and distance and EIGRP. Okay, here you can define, this is the only option, nothing to discover else. Okay, another way, now again router is performing load balancing, so IP route EIGRP, not performing load balancing, let me up the upper path also, interface G0/0 no shutdown. Again R1 is performing load balancing, so IP route EIGRP, soon it will perform, you can see, right? I had told you through offset list you can add any value in the matrix, so with the help of offset list, how I can achieve path manipulation here, or on any router, like on router number 1 you can configure path manipulation, on router number 2 also. From router number 2 also there are two paths to reach in this subnet, 192.168.2.0, right? So it should be, this path should be the primary path and this path should be backup path, so that whenever primary path will goes down, router will not generate query message. Through offset list, first I need to match the prefix, right? For that I will create ACL, access control list number, let's say 10, permit 192.168.2.0 while karma 0.0.255. This is my access list which is matching this subnet. Now I will go to router EIGRP as number 10 and do so IP EIGRP topology. Here you can see which path is the successor. Load balancing is happening. Here is the FD and here is the RD. So in the lower path I am going to add some more metric for path manipulation. So my existing metric is this one, let me copy, and inside router EIGRP I am going to say offset list and access list number 10 in direction in, like when you will receive the update message, and let's add how much metric, let's say 50. I'm adding 50 more on G0/0 interface. Whenever router 1 will receive EIGRP update message on G0/0 and subnet will match from the ACL number 10, then it will add this value 50 in their metric, right? So one path will have higher metric, one path will have lower metric. Let's do it on G0/1 interface so that my lower path can be the backup path. Okay, now do so IP route EIGRP. Still load balancing is happening, but wait for, now you can see best is via router number 2. Why? Do so IP EIGRP topology, because here we have added 50 in metric, right? Earlier metric was 3328, now 3378. We have added 50 more. This is one another way for path manipulation. And from here we can do one more thing. Let me say no to this. What I want, R4 should learn this prefix or should install this prefix 192.168.1.0 via router number 2. Like via router number 2, upper path should be primary, lower path should be backup on router number 4, and I want to configure offset list on router number 1. Means here I will configure offset list in odd direction. Means when R1 will advertise update message to R2, at that time it will add the metric. It will add the value in metric. Like on R4, you can see, go to R4, R4 will be performing load balancing only. So IP route EIGRP. Here you can see for 1.0 it is performing load balancing. Now I will send 50 more matrix from upper path to router number 4 from R1. That is also possible. Go to R1 and say same thing, route offset list number 10, not number 10, because in number 10 we are matching another subnet, another prefix. So access list number 20 and permit 192.168.1.0, 20 192.168.20.0 and wildcard mask 0.0.255. Access list number 20 permit, okay, not 20, 1.0, extremely sorry. Okay, in ACL number 20 I am matching this LAN subnet 1.0. Go to router EIGRPS number 10 and use same offset list command. Offset list number 20, add in matrix by 50 and direction out. Right, so when it will send update message from G0/1 interface, it will send 50 more as a matrix. And now after this ONS neversible resynchronize, you can check EIGRP routing table of R4. Go to R4 and check routing table. Here you can see now best path is via 24.2. Why? So IP EIGRP topology. Here is the answer of your why. What happened? One dot zero. Here it is. Here you can see from router number 3 it is receiving 50 more as a matrix. So in both direction you can add matrix with the help of offset list. Even if I will remove the offset list, say no, sorry, router EIGRPS number 10 and no to this offset list. Here now I am expecting we don't have any offset list, so IP protocol, and so IP protocol C, is there filtering? No, nothing, no any offset list is applied here. Okay, so IP route EIGRP. Now you can see again router 1 is performing load balancing for the destination, as well as router 4 is performing load balancing for destination. So IP route EIGRP. Good guys.
Yes.
Another way is summarization. Now what I can do for path manipulation here on R1, from R1 I can send the summary address via router number 3 to R4. Right, now you can see R4 is receiving individual prefixes. Right, let's say here I have multiple submit like this, 10.1.1.0/24, 10.1.2.0/24, right, or you can take multiple from 192 range as well, 10.1.3.0/24. Let's say this subnet. What will be the summary address of this 3 subnet? In last class also we have seen the summary address. For summary address you need to convert third octet value where change is there. So change is in third octet only. Summary address is going to be 10.1.0.0/22. What will be the subnet mask for /22? Subnet mask for /22? 252. 255.255.252.0. This is going to be subnet mask. So if I will advertise the summary address from this interface, let's say 10.0.0, 10.1.0.0/22, then router 1 will not advertise these individual prefixes. Then router 4 will receive summary address from R2 and all the individual prefixes from R3. Both are different subnet. Now R1 is advertising total 4 subnet. This is summary address and 3 individual prefixes. Summary address via router number 2 and individual prefixes via router number 3. So in that case, again your router 4 will start forwarding traffic via lower path. Again, that is path manipulation. Let me show you. Go to interface G0/0. IP summary address for EIGRP as number 10 is 10.1.0.0 255.255.252.0. That's it. IP summary address EIGRP 10, and here is my summary address now. So IP route EIGRP. First of all, you can see router 1 has also, sorry guys, these loopbacks are not created yet. Interface loopback 10 IP address 10.1.1 255.255.255.
Raful, it's not look back 10. It's 110. You say look back 110.
Loopback 13 3.1. So here I have added 3 more loopbacks on router number 1 where I have run these networks, this subnet. Okay, now so IP EIGRP topology. In EIGRP topology, you will find all the 10 subnets as well. Here you can see router 1 has calculated the metric FD value. Now it will advertise to their neighbor R2 and R4. Go to R4 and check. Sorry, before going to R4, check here routing table of R1. So IP route EIGRP. In EIGRP routing table, you can see it has installed this same summary address in their local routing table as well to avoid loop on null 0 interface. And what is the AD value of this prefix? Distance. If you want to see the detailed information of any prefix, then open it like this. So IP route and 10.1.0.0 10.1.0.0 like this. Here you can see the detailed information about this subnet, which are part of my routing table. And here you can see distance value is 5. So EIGRP uses AD value 5 for summary address. Now if I will take you to R4, then see here, so IP route EIGRP. It is learning all the 10 subnets, all individual 10 subnets via which router? Via router number 3, and summary address via router number 2. So if I am going to send traffic from here to ping 10.1.1.1, where router 4 will send the traffic? To R2 or R3? To 24.2 or 34.3?
34.3.
34.3 definitely. Here 24 bits are matching, right? So summarization is also one way to manipulate the path, and you can reduce the routing table as well. If I will advertise summary address from both sides, this way you can reduce the routing table size. Go to R1 and advertise same summary address from another interface also. Interface G0/1 and summary address this one. And now on router number 4, you will be getting summary address only from the both side, and it will be performing load balancing. So IP route EIGRP. Here you can see 10.1.0.0 summary address and performing load balancing because of same AD value and same metric. These are different ways for path manipulation. Now can we start route filtering? See in the routing table of router 1.
Using the load, can we filter the means? Can we filter the CC for? Sorry, can we manipulate the path
Sorry,
using the load?
can you repeat?
Yeah, using the load. Can we
Using the load.
Can we? Yes,
What is load?
the matrix of K2, I believe.
Metric component K5.
Yes. No, I think it's K2, I guess.
K2, using K2. Definitely you can perform path manipulation. Why not?
Okay. So for that, the higher values for which one is
First of all, you
preferable?
have to configure EIGRP to use K2 value, right, for metric calculation. When router will be using load, then only you can perform load path manipulation using load. Whatever components it is using, we can use that for path manipulation.
But we should have the K value same, right, for neighborship?
Exactly. Then
Then
only
if it's
neighborship will come up. So on
then if
all the router, you have to change the K values, bro. If K
okay,
values
then
are not same on all the router, then neighborship will not come up. When neighborship will not come up, they will not exchange any route. How you will perform path manipulation?
Yeah, but
okay.
usually by default, the key values are all the same, right? Unless we change them, right?
By default, routers uses only K1 and K3. Rest all K values are unused.
Okay.
So IP route EIGRP. Should router 1 install this network in their routing table 34.1.1.0, 24.1.1.0? No. Right? Or maybe R4. R4 has installed the summary address. So IP route EIGRP. It is learning this LAN subnet as well as 10.1.1.0 summary address. But let's suppose from router number 4, we are not sending any traffic in this subnet. You have to filter that from the routing table. Unwanted prefix means not used prefix, which are not required in the routing table of router. Those prefixes are called unwanted prefixes. And we are learning route filtering to filter those prefixes only. All unwanted prefixes.
And you said there's different ways to filter the route, right?
Correct. Route filtering. Used to filter unwanted prefixes from the routing table, right? So to understand the route filtering, you have to understand distribute list. We have seen in all the routing protocol, we have distribute list. Distribute list is used for route filtering actually, right? Through distribute list, we are filtering a route in the dynamic routing protocol. Distribute list is used to filter routes or prefixes. And distribute list can work with standard ACL. It can work with extended ACL. It can work with prefix list. And it can work with route map. I can use standard ACL, extended ACL, prefix list, or route map inside the distribute list. Why? To match and deny the prefix. To match the prefix and to define the action. Deny or allow. If you want to allow some prefix, you will use permit statement in ACL. Similarly, permit statement in prefix list, permit statement in route map. If you want to deny any prefix, you will use deny statement, right? Let's suppose I have a router R1. R1 is connected with lots of other routers. Here we have lots of other routers, and R1 is learning some prefixes. 100 number of prefixes means 100. It can be 100 class full networks or 100 subnets, doesn't matter. 100 prefixes means 100 network information or 200 network information. So by default, whatever prefixes neighbor router are advertising to R1, it will install in their topology table. All 200 prefixes will be installed in the routing table of router 1. But suppose R1 only ping 2 or send traffic to 20 prefixes out of 200 prefixes, means there are 180 unwanted route. You need to filter that, not from the routing table only, from the topology table also. So what is distribute list? Distribute list, you can say it is a tool which is used to filter prefixes. But who will tell prefix distribute list to allow or filter which prefix? For that we have ACL prefix list and route map to match the prefixes or network information. Let's understand very basic route filtering with standard ACL and distribute list. Standard ACL, let's suppose a router, this R1 only, is learning some prefixes like 10.1.1.0, 10.1.2.0 slash 24, 10.1.3.0 slash 24, 10.1.4.0 slash 24, and 10.1.5.0 slash 24. So neighbor routers are advertising these prefixes to R1, and you don't need 10.1.3.1, let's say 3.0 slash 24 on R1, right? This submit is not required in the routing table of router 1. How you will filter this with the help of a standard ACL? Very simple. Syntax is going to be access control list, access list number 10, and deny 10.1.3.0, 0.0.255, and access list number 10 permit any, right? Means rest all the prefixes are permitted and 10.1.3.0 is denied in this ACL, in ACL number 10. Now to apply it inside EIGRP, router EIGRP yes number 10 and distribute list, call your ACL number 10 and direction. So in which direction I will apply this ACL?
In direction.
In direction.
Out.
Means whenever
In
it will
direction.
receive the update message, whenever it will receive the update message for these prefixes, it will check ACL number 10. Okay, like here we can check it. Let's say R1. On R1 show IP route EIGRP. Okay, let me filter 34.1.1.0 config t router EIGRP ES number 10 distribute list number 10 ACL number 10 or ACL number, let's say 50, direction in, and in ACL number 50 I am going to say access list number 50 deny 34.1.1.0 wildcard mask 0.0.255 and access list number 10 permit any. That's it. So access list, here you can see my ACL number 50 and so IP route EIGRP. Now you can see what happened here. All the prefixes are filtered. Why?
We have not given the interface.
So run section access list. What we have not given, sir?
Interface.
We have not given the permit statement, right? You have to permit rest all. So access list number 50 permit any. Now wait for the EIGRP resynchronization or update. So IP route EIGRP. Now you can see 34.1.1.4 is filtered. But I don't want to filter like this. Praful, whatever here we have list wanted prefixes like this 192.168.2.0. Router 1 should only install this network in their routing table, not anything else. And their summary address maybe the self advertise. Even I am going to remove the summary command. Do so run interface g0/0. Say copy the command summary address command and say no interface g0/0 no to this. And one more command is there, that is do so run interface g 0/1. Here I have this summary address, let me remove it. Interface g 0/1 no to this. And so IP protocol. So IP protocol. See, so IP protocol is going to tell you is there any filtering applied or not. Here you can see my routing protocol is EIGRP number 10. Outgoing update filter list for all the interfaces is not set, but for all incoming update filter list for all the interfaces is ACL number 50. Is ACL number 50. This is your distribute list configuration. Do so run section EIGRP. Inside EIGRP, you can see distribute list number 10, 50 direction in. Let me remove it. Router EIGRP as number 10 and no to this. Now we have all the prefixes, wanted as well as unwanted prefixes in routing table, EIGRP routing table. So IP route EIGRP. Here you can see even 34 should be also there. 34.1.1.0 to 192.168.2.0. So only this is my wanted prefix. I only want this one in routing table, not anything else. So I will filter like this: access list number 60 permit 192.168.2.0 and wildcard mask 0.0.255. So I have only allowed this prefix in ACL number 60. Rest all are denied. By default, deny statement is running at the end. Now use it in your EIGRP router EIGRP as number 10. Distribute list number 10. Sorry, not 10, 60 and direction
in.
in. And wait for EIGRP update message. Then check your EIGRP routing table. Now you will have only the destination LAN subnet, nothing else in routing table. So IP route you can see. Now the EIGRP routing table is fair and clear. So this way you can filter the route through a standard ACL. But what is the limitation of a standard? Yes, go ahead.
This is not standard. This ACL is not. It's not standard ACL.
This is not a standard ACL. Standard.
Excuse me?
You are asking or you are telling me, brother, that this ACL is not a standard ACL?
Me, I wanted to ask, but I don't know.
No, I'm asking.
This is a standard ACL only. Range of a standard ACL is 1 to 99. So 60 is in between only, no?
Oh yes.
Yeah. My question.
Go ahead.
May I do?
Yes, sure.
Okay. Now we have this. Only we have this in the table, routing table.
Okay.
At this time, everything can communicate, and then can we ping from router one to others?
Yes, definitely.
Or the path is, it doesn't affect the path?
No, nothing. See, ping
okay.
192.168.2.1.
Okay. So why we have to erase everything from the table?
Sorry?
Is there any reason?
Yeah,
why
I
we should
have
have
removed it from the routing table so that router will not install unnecessary route in the routing. If router is storing that, it is using their memory,
I got it.
CPU.
Okay.
So
I got
IP
it.
route 192.168.1.0. Let me take you to the PC and let me say IP 192.168.1.1/24. And what is the gateway IP address? gateway. So IP interface brief 100 1.192.168.1.100. Go to PC2 also. IP 192.168.2.1/24 and 192.168.2.100. So can PC1 and PC2 talk with each other? Ping 192.168.2.1. See, ping is working. But you cannot ping from router, from R1, because we have filtered the route. We have filtered all the LAN to LAN communication is still there. If source is going to be
Okay, what
12 or
about
plus,
from PC to router?
definitely you can ping PC to router to the gateway. You
Okay.
cannot ping R2.
Okay.
You cannot ping R4, not R3. You can ping your gateway and the destination LAN. On router number 4 also you will filter all the unwanted prefixes. On router number 4 also I am going to say config T access list number 60 and permit. What is the wanted prefix here? 192.168.1.0 only, while karma 0.0.255, and I will call it under router EIGRPS number 10 distribute list number 10 direction, sorry, not 10, 60 direction in. On router number 2 also we can filter the routing table. On router number 2 both are wanted, so config T access list number 10 permit 192.168.1.0, 0.0.255 and 2.0. Only these two subnets are allowed, rest all are denied. Router EIGRPS number 10 distribute list number 10 direction in, and go to router number 3 and just repeat this configuration. Access list number 60 permit 192.168.1.0, 0.0.255 and 2.0, and router EIGRPS number 10 distribute list number 10 direction in. Now on any router you can check the routing table. You will find the clear and clean routing table. So IP route EIGRP. See the routing table of R1. See the routing table of R4. So IP route EIGRP. Only the destination LAN subnet. Check the routing table of R2. So IP route EIGRP. Only LAN subnets. And on R3 also. So IP route EIGRP. Here I think filtering is not applied. So access list. So access list number 60. So IP protocol. Here I have called ACL number 10. It should be 60. So router EIGRPS number 10 and do so run section EIGRP and say no to this distribute list and say distribute list number 60 direction in, and so IP route EIGRP. Soon it is going to filter all the prefixes. Now you can see the routing table of R3. Right, so if routing table of router is clear, you will get better performance. This is route filtering in EIGRP through a standard ACL. What is the limitation of a standard ACL? A standard ACL only match source. We cannot match the destination. Let's suppose I have router number 1 here, R1. This router is connected with one switch, let's say multi-access segment, and the switch is further connected with two router, R2 and R3, and here we have same R4. Now the connectivity is different, like physical connectivity is different. Again we have 4 router, again we have 2 paths between source and destination, but here I have added a switch R1 switch 1, R2, R3, R4. Let's say R4 is advertising a subnet or 40.1.0, 40.1.0/24. Right, here my IP address is, let's say, 12.1, 12.2 and 12.3, right, with /29. I'm using the subnet 0/29. In this case, R1 will run this 40 subnet 40.1.1.0/24 via 12.1.2 as well as 12.1.3. Here I want to filter, let's say, 40 subnet via router number 2. I don't want to receive 40 subnet from router number 2. Can I do this? Can I perform this filtering with the help of extended ACL on R1? Definitely you can do on R2, right? During advertising update message, we can filter this 40 subnet. On R1, can I filter from a specific source? No, we can't. Right, because here in extended ACL you can only match 40. You cannot match 40 when 40 submit is coming from 12.2. right, you can match source and destination in extended ACL only. Here you have to configure extended ACL if you want to filter route from any specific source, then extended ACL. Got it? So in through extended ACL, how I can achieve this? Through extended ACL. Through extended ACL, I can say access control list, access list 101, deny protocol IP 40.1.0 wildcard mask 0.0.255. Anything else? It will deny the 40 subnet. Here I will configure like this: IP, and when it is coming from host 12.1.2 and the destination is 40.1.0 wildcard mask 0.0.255. This is going to be your ACL access list number 101, permit IP any rest all are permit, and router EIGRP ES number 10, distribute list 101, direction in. Right, so now router 1 will filter 40 subnet when it will receive from 12.2, not from 12.3. So it will run this 40 subnet via.
Excuse me, Praful. So in your statement, deny IP host, you put
Source.
the source.
Yes.
We don't need the wildcard for the source.
No, if you have defined the host keyword here, it means you are talking about /32.
Specialist source. Oh, okay, perfect. That's true. Thank you so much.
Couple one quick thing, question. So if we remove these prefixes, will the end users able to connect to that particular subnet or not?
Yeah, still prefix is here via router number 3. Prefix is still there via router number 3. Just I have filtered 40 submit via router number 2. If prefix is not present in the routing table, router will not take any forwarding decision. User can not communicate.
Cannot communicate. Okay,
Robert?
thank you.
There is a bit confusion, I think. Is it to filter the IP
Host.
address from router 4?
It is used to filter 40 submit on router number 1 via router number 2. Not on router number 4.
So, but both are the same subnet, I think.
Which are?
Router
Where
1
have
and
you
router
said?
4.
Router 1 has learned this subnet through
40.1
EIGRP protocol.
dot
Bro.
1.10 40.1.10.
It has learned through EIGRP from router number 3 via 12.1.3.
Ah, okay.
You can do this with the help of prefix list also. Through prefix list, your command is going to be this IP. See, before that, let me tell you just few things about prefix list here. Prefix list. What is prefix list? We can filter route using prefix list, or by using prefix list through prefix length. Right, whenever you want to perform filtering or you want to match some prefixes with the help of prefix length, you will always use prefix list, not ACL here. Through ACL we are matching what? Number of network bits with the help of wildcard mask. In prefix list you can match the length of prefix, right? There are some terms
It's
in prefix list
it's more specific.
called, see, we can filter
Prefix list.
by using prefix list through prefix length. In some cases, prefix list is better than EIGRP for route filtering. You want to match the prefixes. In BGP also you will see. In ACL, there is gap of 10 in each statement, correct? Like my first statement will get sequence number 10. My second statement will get sequence number 20. If you want to define the sequence number, you can define during configuration as well. But by default, there will be increment in sequence number by 10 between the ACL rules. Here in the prefix list, you will have gap of 5. Gap of 5 means first statement will get sequence number 5, second will get 10, third will get 15. There will be gap of sequence number 5. Now there are some terms in prefix list. One is LE. LE means less than and equal to. What I told you, prefix list is used to filter prefixes with the help of prefix length. So through LE, what I can define, any prefix whose prefix length is less than and equal to, let's say 26. Right? Now action is anything, maybe permit, IP prefix list permit 40.1.1.0, 40 dot or 40.0.0.0, whose prefix length is less than and equal to 26, means 26, 25, 24, whatever prefixes are there whose prefix length is less than 26 will be filtered or will be matched. The another component is GE. GE means it is less than and equal to, and GE is greater than and equal to, greater than and equal to, right? Like same /27, the prefix whose prefix length are equal to 27 or greater than 27, I want to filter that or I want to allow that. And the third component is 0.0.0 means 0.0.0 means, you know, any. These are the components of prefix list. Let's say on router number 4 I have some subnet like this, 40.1.1.0/24, 40.1.2.0/25, 40.1.3.0/26, 40.1.4.0/27. We know, but like we have different size of departments. Based on number of required IP address only you will perform subnetting. VLSM. VLSM means what? The length of my subnet is variable. So here through VLSM we have calculated this subnet 10.1.5.0/28, 10.1.6.0/29. These all are different subnets, and you can see different subnet has different prefix length. Based on prefix length, I can control the route on any router using prefix list. Right? So if I am saying, let's say one statement, deny 40.1.0.0 means here doesn't matter what is the value in third octet and fourth octet. In first octet the value is 40, in second octet value is 1. Then filter prefixes whose prefix length deny 40.1.0.0 whose prefix length is less than and equal to 25 and greater than and equal to 27. How many prefixes will be filtered? How many prefixes will be filtered? Will it filter this one?
31.
2.0/25. Will it filter this one?
Yes.
Yes. This one?
Yes.
This
Yeah.
one?
No, not the second one. Not 26.
Yes, 26 also, brother. 26 is.
I don't know. What he wrote is
Sorry.
less than 25, greater than 27.
Sorry. 1 minute. Let me correct it.
Swear me?
Correct it. Let me correct it. Let's say this is my statement only. Less than 25. Then will it filter this one? Yes. Less than and equal to /25 will be filtered. 24. Yes, it will be also filtered. 26 will be not filtered. And if I am seeing here greater than 25, how many prefixes will be filtered? Greater than 25?
5.
From 25 to 29, all these prefixes will be filtered. And if I am saying one thing here, deny 40.1.0.0 whose prefix length I am saying /27, sorry, 16. See, this is the correct way to configure prefix list. Deny 40.1.0.0/16 means here my 16 bits are network bits, and now I will define the greater than and less than value. Greater than and equal to 25 and less than and equal to 28. This is the correct statement. Now here tell me how many prefixes will be filtered. First of all, these all prefixes will be matched in this entry, in this statement. Yes. Now the prefix length from 25 to 28 will be filtered. 25 to 28, these all prefixes will be filtered, correct? These all prefixes will be filtered from the routing table if I will use this
Correct.
prefix list. And for rest all I need to allow. So what will be my statement? My statement is going to be permit permit 0.0.0 /0 whose prefix length is less than and equal to 32. Right? Allow all the prefixes whose prefix length is less than and equal to 32 and prefix is any. That will be allowed. So here on router number 1 or
Sir,
any
can you
router,
just go to the paint once?
here it is.
Sir, you filtered the statement is said that 40.1.0.0, right?
Correct.
And how it's going to filter the 10.1.2?
It is not 10, bro. It's 40. It's mistake. It's 40. Okay.
Okay. Sir, if I don't use any less than greater, then it will be work or not?
Yes, definitely it will work. It will filter all
In that,
the subnet. Okay.
sir, all the subnets means the /16 will be going to or
Yes, /16. With /16 it will filter.
work. Okay.
Okay. Anything else, guys? In prefix list? Okay. See here on router number 1. So IP route EIGRP, and on router number 4 I'm going to create some loopbacks. Config T interface loopback 10 IP address 40.1.1.1 255.255.255.0 interface loopback 11 40.1.128 with /25 2.0 loopback 12 subnet mask will be what /26 /27 what will be the subnet mask
224.
224 great
240.
240.5 and 248
48
6.1
and 52.
252 7.1. Okay, but these prefixes are not allowed on router number 1. Only 192.168.2.0 are allowed. So IP route EIGRP, you can see we have not received it. So let me change the add some statement in ACL. Do so access list. First of all, I have to check which access list is applied under
60.
EIGRP. Do so run
EIGRP 60.
section EIGRP 60. So IP protocol. EIGRP 60 is applied. So go to do so run section EIGRP and do so router EIGRPS number 10 say no to this. Now see, I am expecting again all the prefixes on router number 1. In the routing table of R1 I am expecting again all the 40 subnets. And see, I want to filter all those prefixes now. So IP route EIGRP. Now you can see these prefixes are here but not 40. Let me take you to R4 and so IP route also IP EIGRP interfaces. Okay, EIGRP is enabled on all the interface. Why we are not able to see these prefixes on R1? 40 prefixes because R1 is R2 is also filtering, R3 is also filtering. So R2 will even filter all the unwanted prefixes. Router EIGRPS number 10 do so run section EIGRP. Now to this distribute list and do so history not visible. Go to R3. I have applied the filtering in direction only, so no need to remove from the R4. Router EIGRP 10 do so run section EIGRP. No to this. Now I am expecting all the prefixes again in the routing table of R1. So IP route EIGRP. All 40 prefixes are there. Here you can see the subnet mask like prefix length 24, 25, 26, 27, 28. Let's say I want to filter and let me add one more loop back here on R4. Interface loopback 20 IP address. How many subnets are there? 5, 6, 7, 8. I am adding 8 as well. With subnet mask 40.1.8.0, 8.1, 255, 255.244. .254 is not going to be subnet mask. IP address 40.1.1.40.1.8.1 255.240. This IP address is overlapping. Okay, 252. Sorry, R1, and now check 7.0, 8.0. So prefixes are there with different slash values, different CIDR value from 24 to 20, 24 to slash 30. Let's say I want to filter all the prefixes whose prefix length, right? Prefix which is matching in 40.1.0.0 and whose prefix length is 0/16 from this subnet, whose prefix length is greater than and equal to 25 and less than and equal to 28. You can't achieve this with the help of ACL. You have to run lots of statement, right? Prefix list can simplify the statement. Through single statement you can do that. Config the IP prefix list, name of your prefix list, let's say CCNP, and then deny 40.1.0.0 wildcard mask or /16, then greater than and equal to 25 and whose prefix length is less than and equal to 28. It is like this. So simple. Do so prefix list. So prefix, so IP prefix list. Here you can see your prefix list with sequence number 5, the first statement. And here I have to add one more statement, that is IP prefix list CCNP permit. I want to allow rest everything else. So permit 0.0.0/0 and less than equal to 32. Whose prefix length is less than or equal to 32. Now show IP route EIGRP. In EIGRP routing table you can see prefix with /24, /25, right? Nothing is filtered because I have not applied it in the EIGRP. So router EIGRP is number 10, and this time distribute list I will not call to ACL, standard ACL or extended ACL. I will call to prefix list. So prefix list, name of your prefix list is CCNP, and then define the direction. What should be the direction? In or out? Direction should be in here, right? Clear IP EIGRP or wait for update synchronization. So IP route EIGRP. See 40.1.1.0/24 is there, then 29 is there. So 25 to 28 is filtered, right? If I want to filter all the prefixes with /24, if you want to filter all the prefixes with /24, then what will be your statement? I don't want this router should learn any prefix with /24, right? Like sometime you will have requirement router should not learn prefix with /8 because /8 is lengthy route. So many IP addresses are there, right? Let's say ISP, you have purchased the connectivity, WAN connectivity from ISP. Your edge router is connected with internet. So here you are paying for one public IP address only. Slash value should be what? /30. Router should be only allowed to install /30 prefix in their routing table. That is also one requirement there between two routers. For that your statement is going to be like this: IP prefix list and name of prefix list CCI, let's say, and prefix is any 0.0.0/0 means any prefix whose prefix length is greater than and equal to 24 as well as less than and equal to 24. What will happen here? All the prefixes with prefix prefix length 24 will be filtered. Or if you want to filter all the prefixes with prefix length 24 to 25, you can do that also. Greater than or equal to 24, less than or equal to 25. So it will filter all the prefixes whose prefix length is 24 to 25. The subnet doesn't matter, any subnet. If you also want to define the subnet, you can do that. And then you can call your prefix list in EIGRP. The last,
So,
yeah.
Praful,
Go ahead.
I have saw some prefix lists which they are defining the it goes like this: prefix list.
Okay.
Then they give the name of the prefix list and they give sequence number and permit. Then they write the IP address
Sequence number.
and the sub. Yeah.
Let's say 6.
Yeah.
Okay. Then
The IP address.
a statement action should be deny or allow.
No, for this one I don't see there is no statement. It's just a prefix list.
What is your requirement? Tell me the requirement.
Let me just read it for you. It's a prefix list. They give the name of the the name of the prefix list.
IP
Let me just say
CCIE. Sequence number 6 or 10.
Permit.
Anything. Huh? Permit.
Then the IP address. Then
Which
10
IP?
dots.
10 dot.
10 dot.
1.0.0
/24. Yeah. So what this signifies?
It is not going to filter anything. There is no any prefix where these 3 octet will match. I don't have any prefix like
10.10, and for the third octet there is a number there.
So
there
slash
should be,
should be 16, na then /16. It is going to match these 2 octet value. In first octet value is 10, in second octet value is 10. Then your prefix list will be applicable. After that, greater than and equal to. Okay, it's easy and
Raful, can we use equal to? Only equal?
No, you
not
cannot
less than,
use
not greater.
No, not only equal to. Here
Okay.
you can see.
So Prabhu, what is the sequence number? What's the meaning of the sequence number?
Sequence number. What is sequence number in TCP?
I don't know. That's why I ask.
Like see,
According
if you have
to the
2
sequence.
statement, how you will identify which statement is first one and which one is second one? If you have 2 statements. If you have two routers, how you will identify which router is router 1 and which router is router 2? You will define the name, na? R1 and R2. Correct? R1 is first router, R2 is the second router. Similarly, when we are configuring multiple statement, sequence number is going to define, router is going to check which rule first. When we have multiple rule, how we will arrange those rule in a sequence.
Okay.
With the help of sequence number.
Okay.
Okay. So see, prefix list is similar like ACL, but here through prefix list we can control the prefixes based on length of prefix. The third component which I can use inside the distribute list is route map. So in next class we'll see the route map, basic of route map, and I can show you one filtering with route map. Like see, on the router, let's say on R1, so IP route EIGRP. So IP route EIGRP. I want to filter those prefixes whose matrix is, let's say, 3072. I want to filter prefix whose matrix is 3072. Can I do it through ACL? No. Can I do it through prefix list? No. In ACL prefix list, I don't have option to match matrix, but you can do it through route map. So route map allow you to match various things like matrix, source, destination, next hop, right? So many parameters. Like you can use one command, route map Cisco permit sequence number 10 and match, put question mark. See, you can match ES path. This is BGP attribute. You can match the BGP community. Later you will learn this. You can match the interface. You can match the protocol IPv4, IPv6. You can match the length. You can match the local preference. Again, one attribute of BGP. You can match the matrix value. You can match MPLS label. You can match route type. You can filter internal route, external route, any route from any source protocol, like filter EIGRP route, filter OSPF route, filter RIP route, filter a static route, like that. You can also match the tag and track number, right? So we have various components to match in route map. But again, route map is also a statement and action, a statement with action, right? We are going to define the match a statement, and based on that we'll take the action. So this statement is going to permit whatever I will match. Now I want to filter any route with matrix, so I will create route map like this, route map Cisco deny sequence number 20, and then I will say match IP address from ACL number as well. I can call my access list. Whatever prefix will match from that ACL, that will be filtered. But this is the same thing for full. So we can match multiple things. We can match prefix from ACL as well as we can match the matrix. If the prefix is matching in ACL number 10 and also has this matrix 3072, then only deny. Getting my point? Match here matrix like this. Okay, so tomorrow I will show you some route filtering with route map. Hope standard ACL and prefix list is clear, like route filtering with standard ACL and prefix list is clear. One minute. हाँ दे दो चलेगा. Okay, everyone, that's all for today.